something actually fails to put a message, so I need to again so have a mechanism to store this message on database like failed messages and then reprocess them via cron jobs or something like that. Right. So again, we are having a hard dependency on this layer, like Kafka layer or middleware layer. Okay. So that is one of the complexities like which we see. So I'll just go back to like how we can actually solve like or how Kafka can address these kind of issues, and then how we can actually make sure that it is resilient and then there are no failures kind of thing. Okay. So before actually going with Kafka, so I wanted to introduce like so few other items like what a message queue is actually like. So evolution is something like this. Initial days we used to have HTTP services. From HTTP services, we had like messaging queues like MSMQ or other queuing systems. Okay, so later like we had the message brokers. So one example of message broker is like a RabbitMQ or RabbitMQ. So later like we had so Apache Kafka and then Kinesis, which is provided by like or Apache Pulsar. So these are all like some of those latest technologies which are continuously evolving. So let me actually introduce you like what message queue is actually. So a message queue is nothing but like let's say this is the process A which is actually trying to communicate with the process B and C and D. Okay. So what this process A actually does is, so in our case we can take this process A as warehouse management, and then process B and C can be like all these subsystems like package delivery system, finance team, and other teams. Okay. So in this case, what message queue is actually does is like, so the message queue, the producer, so you can consider this as a producer. So this continuously produces messages into the queue, messaging queue. And once we receive this message, so these messages are actually delivered onto subsystems. Okay. So there is a drawback with message queues. For example, like I have three messages here, 1, 10, and then 20. So this message, so with the traditional messaging queue system, so what happens is like, so any message, so even though you have like multiple processes that are listening to the queue, so the message is actually communicated, like it actually goes with only one system. It actually goes to only one system. Okay. So for example, like I'm just sending like three messages, 1, 10, and 20 into the messaging queue. So the messaging queue, so it delivers 1 into process B, 10 into process C, and then 20 into process D. So this one, once it is actually consumed by process B, so it gets deleted from the queue itself. So it is not actually sent to process C and D. Okay. So any questions still? Like I just wanted to check, or if I'm going fast or something like that. So if there are like any questions, so you can simply raise a hand. Or I see like if I'll get any notifications. So or am I clear till this point? Okay, so I hope like everyone is actually following. Yeah. Um, Yeah. So one disadvantage with which we see with the messaging queue in respect to our use case. So our use case is something like this. So we want to deliver the message order details to all of these systems, to finance system, packaging and delivery team, and there are like other teams who are actually interested in this messaging queue, in this message. But with messaging queue, so that is not actually possible. So let's say like if I deliver a message, so the message gets delivered to either of these, so it is not actually delivered to all the three items. So maybe like if the processing and delivery package, so if it reads the message first, so then the message is actually sent to that service. So if we want to achieve the similar kind of situation, so with messaging queues alone, like our use case, so what we need to do is like we need to do something like this. So we need to have like a warehouse management system. So this is like a warehouse. So this should actually send a message into the queue. one queue, and then the message is actually consumed by packaging system. So again, like it, so once it actually process, so it will actually drop this message into another queue, and then it is actually consumed by some other systems. So this way, like we need to have like, so if we want to transfer the data between multiple systems, so we need to actually uh, insert the data into each of these queues. So this is one approach, or you can actually do something like this. So this is in queue, and this is actually consumed by so packaging system. So similarly, like I'll have another queue. So this queue is for finance. So it actually inserts this message over here. And this is again consumed by finance. And if we see, like, this is no way different from our regular HTTP services. I mean, so there are multiple differences, but the amount of failure, like, so the points of failure, or the main from the maintenance perspective, like it is equally. Yeah, so it is equally like difficult to maintain, because like we need to have multiple queues, and then so each of these queues, so it is supposed to be dedicated to one particular item, and it should be listened by so it should be listened by only one particular service kind of thing. So okay, so this is actually with the queue. So I feel like so queue doesn't actually fit our use case very much. Okay, so now let's go back to like, let's see like what some of these characteristics of a queue. So usually like queues, so they either push messages or pull messages. Like they provide like these two kind of options. Like for example, like as a packing system, like I can actually pull messages from the packaging queue, or the packaging system package, this queue itself is capable of actually sending a message back into the packaging system. Okay, so it some systems like they provide push capability, and some systems they provide actually pull capabilities. So also these queuing systems, so they have some feasibility of scheduling a message or creating a delay in the messages itself. Like, okay, so you can actually schedule a message to be sent at like 12 a.m. or it can be sent at like so 1 a.m. or something of that. Or once the message is delivered, like you can actually set a delay period of 5 minutes or 5 seconds, whatever the time might be. Okay, so this is again like one of the characteristics of a queue, like messaging queue. So at least once delivery, like so what this services, like what this queues actually does is like, so let's say like I don't have any of these processes listening, so the queue, the message is actually persisted over here for some persistent, and then once the service is up, like it actually sends the message. Like, so these queues, so they actually guarantee like at least once delivery. Okay, but it is not something like I cannot actually replay the message, so it is exactly once delivery, so the message is actually delivered only once. Okay, uh, so let's say like if we take an example of this one, so this one is delivered only once, so it can be like either B, C, or D. Any of these processes can receive this message only once. Okay, but once this message is received by one of these consumers, so it gets deleted from the queue. And then as it is a queue, like it follows like first in first out approach. So once the message like which gets first, like it gets delivered first. Okay, so these are the characteristics of a queue, like messaging queues. So some examples of messaging queues can be like MSM queue, which I'm pretty aware of. So then comes like a publish subscribe approach. So this is a queue, right? So usually like publish subscribe messages or something like this. Okay, so you'll have a publisher. You can have like multiple publishers, or so even in the case of queue, you can have like multiple publishers which sends data into the queue. Okay, so let's see like what publish subscribe actually looks like. So usually like in publish subscribe, like you'll have a publisher, and then this is the queue kind of thing. Let's assume that it is a topic, and then you'll have like multiple subscribers. So this particular subscriber, so it is sending this message, whereas like this publisher, it is sending these two messages into the topic, like same topic. Okay, so what happens here is like, so each message, so it gets delivered onto all of these subscribers. Okay, so every message, so there is a guarantee that every message is actually delivered to all of these subscribers. Okay, so this actually fits our requirement to some extent, because like, so we as a warehouse management system, like we wanted to send our order details into this messaging publish subscribe system, and then the pub sub will actually take care of delivering it message onto all the systems. Okay, so let's say these are the order details. So um, yeah, so let's say like this is like my one publisher is like my mobile device, and the other publisher is like my web application, and some other we might have like multiple providers, like some might be like an API kind of thing. Okay, so all this actually send messages like related to an order into this particular topic, and all these details are actually distributed onto all these subscribers. So one subscriber is nothing but like our packaging system, the other would be like finance system, and the other would be like some other system. Okay, and all these subscribers, like they actually receive all these messages, and then they can process them. So this actually fits our use case to some extent. Okay, but this has like some problems, or so this is widely used like publish subscribe systems, but yeah. So let's see like what some of these features are. Usually, mostly like these pub sub systems, like the publisher actually sends a message to the topic, and then the message is actually pushed onto all these subscribers. Okay, and also some of these services, they provide the capability of pull. So it all depends upon like multiple providers like SQS, and then we have like Google Pub Sub, we have like RabbitMQ, many. Fan out. Fan out is nothing but like one difference between the messaging queue and then the pub sub systems is, so this particular message, so it is not actually duplicated. So this is actually present once, and then it is actually transferred only onto one particular consumer. So whereas like in case of like pub sub, so this message, like it actually gets duplicated, and then it is actually transmitted onto all of these particulars, all of these consumers. Okay, so that is what like a fan out actually. So it makes a copy of the message and make sure it is actually delivered to all the subscribers. So what if a subscriber a consumer actually stops? So let's say like this particular consumer, like this is our packaging system, right? So what if this consumer actually stops? So with the pub sub, like there is no guarantee, like, so this message, so once this so if this actually stops, so we'll have only these two consumers up and running, like one is finance system and the other one is like some other system like shipping cart or shopping cart, some system. Okay, so if this is actually down, again like the message actually is routed to only these two subscribers, so it is not actually sent to this particular subscriber. And once the message is actually delivered to all these subsystems, so the message gets deleted. Like there is no point, there is no way like you can actually send this message back onto this particular subscriber. So you should maintain that particular logic of retrying and resending that message back onto this subscriber. Okay, so this is a drawback of like pub sub systems. This can be okay. Uh, so again, like any questions till now? Like,
so there was one comment from Suresh, if you want to address that.
Yeah, I'll just. We used to have pub sub model even before Kafka with IBM WebSphere. It supports both point to point as well as like pubs. Yeah, so even WebSphere, I'm not pretty aware of it, but there are like other systems like RabbitMQ and others. Like so, RabbitMQ actually supports both. Like so, these are called message brokers. So if we see like WebSphere, so it is actually called as a message broker. So that is what I'll be covering. So we saw like two features. One is like point to point, which is nothing but like message queue, and the other one is like publish subscribe mechanism. So I publish a message and then it gets sent to all the subscribers, right? So these are the two basic mechanisms that we have, like a hybrid approach of having all these like message queues as well as publish subscribe things. So they can be called as like message brokers. So one example is like IBM WebSphere can be called as like a message broker, and then so RabbitMQ. So RabbitMQ has like both of these options. So either you can configure a queue, which is nothing but like point to point communication, or you can have like message uh, pub sub kind of mechanism by having like message exchanges. So there is a concept of like message exchanges. Excuse. Yeah, there is a concept of like message exchanges and then messaging queues. So using these two, like we can actually implement this kind of approach with RabbitMQ. So that might be the case with like IBM WebSphere too. Okay. So I'll just cover this, like why Kafka is more popular when compared to like any of these technologies. Like everything has its own advantages and disadvantages. I'll just go through that. Okay. So we till now like we saw what message queue is actually, and then oops, just give me a second. I'll drink some water. So now let's cover like message broker. So a message broker is nothing but like it's an hybrid thing. So it anything like which supports both like point in point, which is nothing but like messaging queue features, as well as like publish subscribes, they can be called as like message brokers. Okay, so RabbitMQ is one of the solid examples for messaging queues, which I am aware of, but not sure about like IBM WebSphere. So but as per Suresh, like it does something in similar lines, right? So it can be also called as like a message broker. uh, Yeah. So now come back to, so we saw like multiple things, and then so now let's see like what Kafka is. Kafka is something like a distributed streaming platform. So it behaves something different. Like so, in case of like publish subscribe, once the message is actually delivered onto all the subscribers, so it gets deleted. Like so, you don't have the ability to replay the message. So let's say like I have 1 to 10 orders, and then I sent all these 10 orders to all these subsystems. Okay, so now there is a bug in my code, or there is a bug in all of these systems, or there is a bug in this particular packaging system. So now I wanted to replay all these 10 orders. So I want to reprocess all these 10 orders. So with any of these publish subscribe or queuing systems, what I need to do is like, so again I need to publish this message onto the queue, and then it is again like consumed by the subscriber. So but there is no point, there is no way like I can actually replay all the messages that are actually stored, replay all the messages like 1 to 10 orders. Okay, so but Kafka, it actually does that. Okay, so and Kafka is a distributed streaming platform, like so, and I'll just go through like how it actually differs from like these queues and then pubsub. So maybe like if I just explain like how what Kafka is and how it internally works, so this clears like some of our previous questions. Okay. Yeah. So let me read all this. So now we have like a warehouse management system, and I have Kafka sitting in the middle. And then these are my third party services where the message is supposed to be delivered. Okay. Yeah, so this is my warehouse system. So it sends a message onto the Kafka, and then the message is actually delivered onto multiple systems, packaging system. So one of the disadvantages, what I'm talking related to the HTTP services. So once with HTTP services, it is like request and then response. So once you send a request, so if they're actually communicating via HTTP protocol, so the warehouse management system, so it should actually send a request to one of these systems and then it should wait for the response. So if there are like hundreds of these systems, so the warehouse management system, what it need to do, so it needs to send this message to each of these services and then it should wait for the response. So it is somewhere like a warehouse system is actually getting blocked. Okay. uh, so that particular thing can be addressed by Kafka. So you can simply drop a message into the Kafka, and this is actually taken care. So it is not. So it doesn't actually know like who is actually subscribing to this particular queue, or it doesn't need to know those details. So it is not aware of any of the details related to the subscribers. Okay. So so the retry mechanism so now actually shifts to either this block or this block. Okay, so if this packaging system is actually down, so it is the responsibility of packaging system to fetch the message from the message broker or message queue or Kafka. Okay, so it is not the responsibility of warehouse, because like warehouse already sent that particular message and this should actually take care of reading the message. All right. So in Kafka, we this is a Kafka cluster, right? So usually like what we have is something like this. So this is like one Kafka broker, and this is another Kafka broker. So when I say like Kafka is distributed, what I mean to say is that so it is actually like so the load, like we can actually, it's like a cluster kind of thing. Kafka can run in a cluster mode, something like this. So this is like server one, this one, and this is like Kafka server two, and this is like Kafka server 3. All of them together, like they form the Kafka cluster. Okay. So this is like node 1, this is node 2, and then this is node 3. So they actually, all of these three, so they actually form this particular Kafka cluster. So when we want to communicate with the Kafka cluster, so this will be exposed via an IP. Like the Kafka cluster together is exposed via an IP. So you can send a message to the cluster, and then that will internally take care of like distributing the message onto each of these nodes. Okay. um, so and at the same time, like the consumers are not supposed to be aware of, like, so it doesn't need to know any information related to these internal nodes. So the consumers actually, they consume these messages from Kafka directly. So this is just an example of Kafka cluster. So one advantage with the Kafka is, when compared to other systems like the traditional pub sub systems or other systems, is so so if we want to, like, so there, like, we are completely depending on this particular pub sub. Like, so one instance of the server actually running, right? So we are sending the message onto this pub sub or this particular system like queue, and then it takes care of like the delivery. So what if this particular cluster, like, so let's say like when I say like Kafka, so people might have a question like, so what if this Kafka fails? Like, so to avoid this failure and to provide like so more resilience and then more throughput, so Kafka comes with a cluster mechanism. Like, okay, so in Kafka you can have the concept of replication. Okay, so what a replication actually does is like, so when you specify, like, so let's say like we queue. Okay, and we specify like we wanted to replicate this particular queue onto 3 different servers. Okay, so I can specify the replication count as 3. And what happens is, so in this case, like I have 3 servers, right? So I can specify like replication count as 2. So let's say like this is my master node and these are like child nodes, S2 and then S3. So what happens is, so the message is actually sent to this broker 1 or so in Kafka, like when you hear the term broker, it is nothing but like it is one Kafka node. Okay. So the message is actually sent to the master broker node, and then it gets replicated onto other two nodes. Okay. So whenever I specify like the replication count as two, the advantage of this replication is whenever like if this particular node it goes down. Okay. So if this node it goes down, so either of these two can act as a master node, and then they can actually serve the data. Excuse me. So they can serve the data without any data loss or failure, right? So so how does like Kafka actually maintain this master child nodes, and then so electing this node as a master node in case like if this parent node, if this node actually fails, so that is again like taken care by like another component which is called as zookeeper. So Zookeeper is another Apache open source project. So it is actually used in many of these big data platforms like so Hive and then other areas. Like so, this is just like a coordinator kind of thing. So this is like Zookeeper component. So what this zookeeper actually does is like so it maintains this information of the Kafka cluster. So it it registers like okay, so now the node one is acting as a master node. So it has like all this information related to the cluster. So it tries to continuously poll these nodes. Like if any node goes down or if something is wrong with any of these nodes. So if one node goes down, okay, so it takes care of the replication. Like so it takes care of like making the other node as like the master node. So the main usage of zookeeper is to just maintain this Kafka cluster. And previously like zookeeper has to do used to do like some additional responsibilities like to which extent like the messages are read or something like that. But Kafka is actually trying to get rid of zookeeper, and it is already in phases like they are doing like so mostly in future releases, like they'll get rid of Zookeeper. Okay, so this is what Kafka architecture actually looks like the broker and then all that stuff. Okay, so there is another concept. So this is like the producer. So I'm just mentioning, right? So this is my this is my producer warehouse, and then these are my subscribers. So what usually I do is like so these let's take like these are my multiple producers. So what they do is like so they write into Kafka something like this. Okay, and this is all like acknowledgement kind of. So you can also get acknowledgement like once the message is actually delivered onto the Kafka system. So Kafka, I am actually talking about these things, right? So the brokers, you have like multiple brokers all together. Broker is nothing but like one node, one particular server, like where we have the Kafka installed. So it has also some features like for how much time the message is supposed to be retained. So maybe you can actually have it for a default time of 7 days, or you can extend it or decrease it. Okay, so you can just see like the process producers writing messages onto brokers. Excuse me. Now let's come back to this consumer section. Like so, it is the responsibility of the producers to send a message onto the broker. That's it. Like it doesn't actually consider like who is actually consuming this message or who is actually subscribing to this particular topic. Okay, so it is not aware. Producer is not aware of any consumer details. Okay. So now coming back to the consumer. Okay, so consumer, what it does is like so Kafka actually doesn't support like push mechanisms. So that means like so we cannot actually push a message from Kafka server onto the consumer. So it is like a poll mechanism. Kafka consumer, so they continuously poll Kafka server, and then they try to get the messages. Okay, so it is forever like polling. It continuously polls Kafka servers. Okay, and whenever like in the time at the time of polling, like whenever it receives a message or a data record, so it just consumes that particular record, and then either it can draw reports or dashboards or whatever it might be like. Okay, so it can consume that message and then process that particular message. So overall, like this is the architecture of Kafka. So these are like producers. We can have like n number of producers. So you can have like multiple systems writing messages onto the Kafka, and then Kafka cluster is nothing but like it's a combination of multiple brokers. A broker is nothing but like again one server. So and then Zookeeper is again like you can deploy it in cluster mode, and Zookeeper takes care of like it coordinates with the Kafka cluster, and then it helps in electing the node, master node, and then replication of data, all that stuff. Like so, whereas like these consumers, they read the messages from the Kafka cluster. Uh, so this now let's go back to some more uh, detail. So how the Kafka actually works. Like so, we saw producers. So a producer is so so just like queues. So we in Kafka, so we have something like so we just saw this, right? So now let's see like how a Kafka cluster like is internally provisioned, or how it is internally architected. So now let me take like one particular Kafka server. Okay. So you can have so Kafka, you'll have something called as topics. A topic is nothing but like it's a logical separation kind of thing. Okay, so I'll have like multiple topics. So this can be my orders topic. Okay, this can be like location tracking topic. Okay, so warehouse management system. So it sends data into orders topic, whereas like other systems like location tracking related systems, so they send messages into the location tracking system. Okay, so this is how like a Kafka server is actually internally, we can assume like something like this. So Kafka server, and these are nothing but like topics. So a topic is something like a queue kind of thing. Okay, so you can just assume it like a queue, but the term used in Kafka is like topic. Okay, so I have like multiple topics. Now let's see like how this particular how the data is actually stored inside a topic, or how the data is separated inside this topic. Okay, so now let's see how the topic is actually defined. So this is my orders topic. So a topic is something how the data is actually written in Kafka is so it actually writes all the data, like all the messages that we send to Kafka. So they are written onto the disk. Okay. So Kafka maintains a log of all the messages which we are sending. Okay. So let's say these are the messages like which I sent. So this is like 0, 1, 2, 3. Okay. So the messages are these are called as offsets. Okay. So these are called as offsets. So these are some of the terminologies that we use in Kafka. Okay. So these are called as offsets. So whenever like we write a message onto the topic, so internally like it is stored as a log format, like so which is an immutable log format. Like we cannot actually delete one particular message or in present in this particular offset, or it is not actually possible. So this is immutable, and this is continuously appended. Okay, so the first message, so this is my first message, second message, third message, fourth message kind of thing. So and these are called as like so these individual blocks, so they are called as offsets. Okay, so you can actually see how my Kafka topic actually looks like. So a producer, it actually sends a message on to this particular topic, and again like topics can be further divided into partitions. So for example, like I can actually so this if I have like only single partition, so this is how it looks like, and if I have like multiple partitions, so it looks something like this. Okay, so this is all my orders topic. So this is my orders topic, and this is actually divided into multiple partitions. So this is something like P1, P2, P3. No. So these are like multiple partitions. So altogether, like this is all called as like my topic. Like this is nothing but like my orders topic. So I'll just get back to this, like what these partitions are actually and how they help this, how they help, and how they are actually useful in Kafka. So usually, let's think that we have only one partition. Okay, so if we have like one partition, so we'll have like only single log entry where we have all these messages appended, like first message, second message, third message, fourth message. Okay, and these are called as like 0, 1, 2, 3. So these are called as offsets. Okay, so these are called as offsets. Okay, so you can actually see, so a topic has like multiple partitions, and then these are the messages: zero first message and then second message, kind of thing. So this will be more clear like when I try to give the demo. Okay, uh, so another example like how the topic partition is actually, so this is like a clicks topic and this is like a upload topic. So producers are actually producing the messages, and then this clicks topic is again further divided into multiple partitions, partition P1, P2, and then P3. So whereas like this is again like the consumer, so this is actually a replica of the topics click and then topics upload, which is replicated onto broker 2. So the consumer, when it consumes the messages, like either it can read the message from replicated server or the main server, like master server. So it doesn't actually worry about those details, like which either it is reading from the replica or like the master node. So consumer actually communicates with the Kafka cluster and it reads the message like. Okay, so this will be like more clear like once we see the demo. Like I have like few demos in line. So this is the anatomy of a topic. Like so, a topic somehow it has like partitions. A topic can be divided into multiple partitions, or it is actually possible to have like a single partition too. Okay. So these are like, this is how like we write the messages. So when we write the messages, so they get appended like so 0, 1, 2, 3, so on and so on. So any questions till now? Like,
Yeah, and
yeah.
hey, Pavan. In the interest of time, I think if you have demos planned, I think if you want to use the
Yeah.
demos to further tune the session, right? Yeah,
Yeah. So let me jump on to the demos. Okay.
yeah, and let us also wait for Q&A, because Airmeet is a forum where if somebody has to speak, they have to come onto stage. So please, anyone, if you have questions, put it in chat or raise your hand and I'll bring you onto the stage and you can talk. Anyone in the group? I see some students also joining. So if you have any questions, guys, let us know. And Pavan, if you want to take maybe 2 minutes to help the student community, like if they want to do something around Apache Kafka, what is the right starting point for them?
So I mean, like the use cases, or so where exactly they can start? Like so technical.
Yeah, where exactly they can start, because they might be in different stages of their student journey.
Yeah. So what I'll try to do is
Yeah.
that, like, so at the end of the session, like I'll provide like few resources, Bharat, and also like I'll be open for any questions, like for the student community, like where exactly they wanted to start, or what use cases they can actually address with Kafka, kind of thing. Okay.
Okay. Yeah.
So that makes sense, right? Yeah.
Yeah. Yeah.
So till now, like we saw what, so on a high level, we saw many of these terminologies, like what a broker is actually, and then what a topic is actually, and then we also went through offsets. We also went through like partitions, producers, and then subscribers, right? So let me actually go through the demo. So in the interest of time, like, So what we can actually do is like, so you can actually go to the Apache site and then Apache Kafka site, and then you can download the data. Uh, so it is very straight. So this will be the first year. Like, okay. So what you can actually do is like, so you can download these binaries, or you can download the binaries, and then you can extract them. So I did that, and this is how like all these binaries they actually look like. So after extracting this, so I'm actually working on a Windows machine, so I'm interested on these Windows commands. So there is a folder for Windows. Okay, so and you'll have like multiple options. Like, so let's go through few of them. Like, so this is the starting session, right? So we'll see like how to create a topic, or how to. So this is all my code, right? So now we, in order to, this is my thing. Like, so initially for communication between the publisher and subscriber, so we need to have a Kafka cluster up and running. So what I said, like, so Kafka is again dependent on Zookeeper, right? So we can simply use this batch files to start this Zookeeper and then Kafka clusters. So initially I'll be starting like, so I'm in this particular folder like C, Kafka, bin, and Windows. So Kafka is where like I downloaded all my binaries. So inside the bin folder and Windows folder, we have like certain batch files. So initially like I'll start like Zookeeper. So we have a batch file for starting the Zookeeper server, like Zookeeper server starts. They all come with Kafka downloads. Okay, so this batch file actually makes use of some properties file. So zookeeper.tab properties. I'll go through this properties file once. So this is like Zookeeper properties file. So you can see multiple options like the data directory. So where exactly we wanted to write all this data. So as I mentioned, like, so Zookeeper actually takes the responsibility of coordinating with the Kafka clusters, and then uh, make sure like, so which one is up and then which one is down, right? So it needs to write some data. So it actually, we can specify like to which directory we wanted to write this data, and we also have like the port, like client port, which port it should actually listen to. So the default port is like 2181. Okay, um, so I'm just starting my Kafka cluster. So it's simply one command. So now once the Kafka is actually up and run, I mean Zookeeper is up and running, you can start like the Kafka server. So Kafka server start batch. So you'll have this batch file, and again like you'll have certain you need to provide the configuration file. Like, so this is the configuration file for Kafka. So it has like something broker ID. So this is my, yeah, as this is like my host machine, and this is not a server, right? So I have only one broker. So I can just specify the broker ID as 0, and it has like multiple options. So which port number we wanted to listen to this, like the default is 9092. So if we want to override, like you can provide your own option. And also like this is another important piece, like, so where exactly do we want to write all these logs, all the data? So I was actually mentioning, right, so Kafka actually writes all the data. It writes all this data onto the disk. Okay, and so we can specify where exactly we wanted to write this, and then default number of partitions. So by default the number of partitions is 1. Like if we create a topic, so by code or programmatically, like we can increment the number of partitions. But so log retention, like, so how much time you wanted to retention the log. So yeah, retention is like 168, so which is nothing but like it is equivalent to 7 days. So Zookeeper connect. So as I mentioned, like, so Kafka is supposed to communicate with Zookeeper, so it should communicate with this localhost 2181. So if we are hosting it on a server environment, so this localhost is supposed to be replaced with the exact IP address of Zookeeper. Okay, so these are some of these configurations related to Kafka. I'm just starting my Kafka server. So don't worry about all these messages. So just ignore them. So now I have like my Kafka and then Zookeeper running. So what I'll try to do is, so I have like one thing. So this is my Kafka. This is my C sharp code. So where I'm just making use of a Kafka client. So I'm just using this package like which is actually provided by Confluent itself, and Confluent is the company which actually contributes majority of the code to the Kafka servers, Kafka code base. Okay, so you can just download this particular package, and we have like multiple high level clients. So they're all called high level clients, and this is for .NET. And for Python, like you'll have multiple packages through which like you can communicate with the Kafka. And similarly you can have like PHP related clients and many other languages. Like, so Kafka is widely supported by many languages, and they have like high level clients for almost all the major languages. Okay, so you can actually see like the producer config. So I'm just specifying like the bootstrap server. So which Kafka IP address I wanted to connect to. So this is my local host. So I have like only one instance running, and it is on my local, right? So I'm just communicating it with localhost, and the port number is 9092. So I'm just building the producer. Once the producer is actually built, so I'm just trying to produce these messages. Like, so I want to produce like, and this is my sample message. So for just for the demo purpose, I'm just trying to send only a small message, something like this. I'm just setting this I value and then appending the date time dot now. So just okay. So and then I'm just appending this particular message. So this is how like we can simply produce a message or write a message onto the Kafka queue. So let me try to execute this particular message, execute this program. So you can simply see this. So you can actually see this. So when we go to this particular message definition, what this message is actually doing. So I'm just posting. It accepts like few parameters. Like one is topic, and the other one is like message, which we are mainly interested in. So topic is nothing but the name of the topic to which like we wanted to post this message, whereas like the message is nothing but like the actual message we wanted to post. So in this case, I wanted to post this message onto the resume processor topic. Okay, and my message is nothing but like this is my message. And this is the message like I'm just trying to post it. Okay, so now let's see, like once we post this message, what happens. So the message is actually posted, so it is actually sent. So now let's observe this particular data. So so we have some key items. So one is like offset, and then partition. So you can see like the offset as 0, partition as 0. And then this is the main thing, like it's a combination of all the above interested items. So topic, partition, offset, like the topic name is resume processor, and then the partition is nothing but like 0th partition, and then the offset is 0. So first message is actually posted. So now let's see like the second message, and then see this thing. So it has like resume processor is my topic name, and then a 0 partition, and then offset is 1. So you can continuously see the offset value gets incremented. So it is actually second offset 2, right? So now we are continuously streaming these messages, and then the offset is continuously incrementing. So we completed this loop. So I just sent like 50 messages, and then these 50 messages, how do they actually look like? So I'm just printing these metadata information, right? So let's see like the metadata. So you can actually see. So I'm passing. This is my message. Okay, and then so you can see like my console log delivered is the text which I'm providing, and then dr dot value is nothing but like the message, and 2, and this is the metadata like topic, partition, and offset. You can see that like I'm posting to this particular topic, and the partition name number is not actually changing, so it is only 0. So because by default, like when we create a topic, so only one partition gets created. Okay, and this is the offset. So if we can relate this particular thing to the message like a previous thing, so it is something like this. So this particular topic like resume processors, it has only one partition, and this is the 0th message, first message, second message, third message, and so on. So like I have 50 messages which were appended to the log, right? So now what I'll try to do is like, so my job of the producer, so this is actually done. So as a warehouse management, so I sent like 50 messages, 50 order details. Just think of this as an order detail. Okay, so I just sent like all the 50 order details into the Kafka. Now it's the responsibility of the consumers to consume these messages. Okay, so I'll just stop this. So as a producer, my job is done and I just exited my program. So I just stopped my producer itself. Like, okay, so now let me start my consumer. I'll actually show you something. So there are like few things which we need to consider here. Like, so this is my consumer configuration. Okay, so I can just specify sample name like for my consumer. So this is usually called as like a group, consumer group. Maybe like we can talk more about this in future sessions. So, and this is the Kafka broker to which I'm supposed to communicate. So Bharat, like if I extend it for 10 more minutes, so that should be fine, right?
Yeah, Pavan. It should be. I hope you also have time set out for Q&A, right? So
Yeah,
yeah.
yeah, I do have like, no,
Yeah.
okay. So this is the main thing like which we should consider, like, so auto offset reset. Okay, so it has like three options. So so one is like earliest and the other one is error and then the other one is latest. Okay, so if we have earliest, so I as a consumer, okay, so now this is my order details, right? So let me actually draw a single. So I have like only I have this is my topic, right? So now I as a consumer, so I'm a consumer, so who is actually trying to read messages from this particular topic. So what I do is like, so initially like if I want to read from the starting message, okay, so I can say offset resets dot earliest. So when you specify this option, what happens is, so it actually tries to read all the messages from the topic, from the first message, okay, from the earliest message. Okay, so this is the configuration, and then this is again like using this configuration we are building the consumer, and then we are subscribing to that particular topic name, so whatever the topic name. So I'm just reading this particular topic name from the console. So I'm subscribing to the topic, and then I'm consuming that message. Okay, now let's see like how this actually goes. So I just wanted to, yeah. So I'm just entering the topic name. So which topic I wanted to listen? So I wanted to listen to this resume processor. Okay. Okay. So I did type it multiple times. So these topic names and all these items, so you can actually read them from database or config values. So so I wanted to read from this particular topic like resume processor. Okay. So I just provided this option of like auto offset to earliest. So I'm just subscribing to this topic like resume processor. Previously, I posted all my messages onto this resume processor. So I'm just consuming this message. Okay, so you can actually see the first message that is consumed is zero, from zero at the partition and then zero offset. And this is my first message, which I'm consuming. So, so I'll just replay this. And you can actually see all these messages, they're actually consumed by these processors. Okay, so now if we see the relationship between like so now when we compare this to the queuing system, like the traditional queuing system, so what the traditional queuing system actually does is like, so it actually sends this. So now we saw like, so this is my consumer test consumer, which is actually consuming these messages, right? So when it comes to the traditional queuing system, so what happens is, so once this message is actually delivered to any of these consumers, so the message gets deleted. That drawback we saw, right? But with Kafka, that is not the case. So what you can actually do is, so I just wanted to specify another consumer, so it can be like another consumer. So this is actually the differentiating factor, like the name of the consumer. Like, so previously it is three. So consumer three, it consumed all my messages. So now like consumer two, it wants to consume these messages. Okay. I'll just hard code this over here. So now this is my other consumer, right? So if you see, like even we can see that this will consume the messages, all these messages. Okay. So this way, like if we have like hundreds of consumers like who wants to process these messages or consume these messages, so they can simply subscribe to this particular topic and then they can read these messages. Why is this possible with Kafka and not with some of those traditional queuing systems like uh, or some of these queuing systems like SQS, Amazon SQS actually doesn't support like replay kind of thing. Okay. So what Kafka is actually internally doing, if we see, so it is actually writing all the data onto the disk. And okay. And whenever like a new consumer comes, so as we already have this data on the disk, so we can simply read the data from this queue. Okay. So this is one advantage of Kafka. So another thing I wanted to cover is something like this. So this is earliest and then so I was talking about the earliest and then latest, right? So let's move this to latest. And I wanted to change. I want another consumer. So the use case I wanted to demonstrate here is, so a new consumer joined the system. Okay, and what it wants to do is like, so it wants to consume only messages from that particular point of time. Okay, so let's say like we have already three messages in queue, and then at this point like a new consumer actually joined the system and it wants to consume only messages from this particular point. Okay, and it doesn't want and actually want to come in, it doesn't actually want to read any messages in the past. So what we can actually do is, so we can specify uh, consumer offset to latest, and then once we specify this to latest, so what happens is you can actually see. So just observe. So at this point, like I'll just click on F10 and see what happens. Okay. So it is not actually doing anything. So it just stopped. Okay. So it is not actually hitting the next line. So as I mentioned, like Kafka consumers are actually poll based. So here in this case, so what I'm saying is like previously I wrote like 50 messages onto the topic from my producer, right? But Kafka, like this consumer, what it wants to do is like, so it wants to read only the latest messages from this particular point. Okay. So there are 50 messages, but this consumer wants to read only messages after that. Okay. So what I can simply do is, so I can execute this producer again. So I'm just executing my producer again, and you can see like when my producer produced uh, yeah, so when my producer is actually producing these messages, so now immediately it came to the next line because it is continuously polling Kafka server, right, a consumer. So once it finds a message, so it gives it to the consumer, okay, for the processing. So now if you see, like previously we wrote 50 messages, so the offset should be somewhere around like 50 or 51, right? Yeah, so the offset starts from 51, so it is reading from 51 messages. And in the same way, like it is reading from 52 messages. So once it reaches, again it completes reading all the 50 messages, so it waits in this particular line, and then it continuously polls for any new messages. Okay, so consumed messages, so it actually consumed all these messages. So this is my producer, so this is delivered, so it delivered all these messages, again like 101 up to 101 offsets, and then it consumed all these messages from 101. So these are like some of those options that are provided by Kafka, so you can actually specify like from which partition you want to read, or you want to read from latest, or you want to read it from the starting. So let's say like if I want to read this particular thing from a specific partition, okay, so let's say like I want to read this message from uh, 35th partition. Okay, so you, as we inserted the data in sequential order, like the 35th message should be either like 35 and then the date stamp, or 36. So let's see like what it is. Okay, so I'm just seeking to this particular partition, 35th partition. Oh, sorry. So I have only single partition, right? So partition ID should be 0. So this should be 35. So you can actually see. So I'm just reading from 35th partition, 35th offset, and the partition is 0, and this is the topic name. This is the topic name, this is partition, and then this is the offset. So what value do we have over there? Like we have 35, and then this is the date time over there. So from now, it will read from, yeah, so it should be somewhere at the top, like this particular line, or else it starts reading only from the 35th message. So it should be something over here, out of above the while. So okay, so I'm just reading from 35th message. So now goes like the 36th message, and so on. So okay.
Yeah.
So
I,
you're
I
able
think
to,
Pawan, yeah,
yeah.
I think this is great. Yeah. And so on, right? Like you have shown the latest option, you have shown other
Earliest
options that,
options.
yeah,
Yeah.
earliest option and so on. I think, yeah, this is great, Pawan, because we are uh,
Running out of
shooting,
time. Yeah.
yeah, 15 past 11. So let's open the forum for Q&A, right? There are already two questions that you have. If you want to take them, and then we can also ask folks to, you know, yeah, raise
Yeah.
hands as
There's
needed.
certain questions, right? Okay, so Bharat, like the question I see is like if the messages are stored, which happens to be the advantages of Kafka, wouldn't storage be a concern for larger systems? I think like nowadays like storage is very cheap when compared to the losing the data, right? So even like SSD, or like you can increment the size of the Kafka, the hard disk on the server, like where Kafka is actually running, and I believe like storage is cheap nowadays. Yeah.
Agreed. Yeah, that's a good point. But is there a expiry that we can set to the storage? Because
Yeah,
you don't want it to go forever, right?
exactly. So this is where like log retention hours it comes into picture. Like you have this configuration option, right? So 168, which is nothing but like I'll just do a small rough calculation. So what is the default value? 20 is nothing but like 7 days. Okay. So the default log retention period
Got
is
it.
like
Yeah.
7 days. So that is like the first message, like this was produced 7 days back, and this is 6 days back, this is 5 days back, and this is 4 days back. Okay. So it deletes the messages. So it checks like, okay, so this message, like, did it reach that retention period? Okay. So if this message reaches the retention period, like it will delete only this message. And the earliest offset will be set to this particular offset. Like one, two, three. So that way, like it will actually clean up all these messages, and forever, like it is not actually required to store any of these messages. Like for example, like some of these healthcare domains, so they have a restriction of keeping all the data for 90 days or something like that. After that, like you can actually delete all the messages. So it all depends upon the business need and individual's need, but that is again configurable. So you can configure it over here, and already once the retention period is reached, so the messages gets deleted. So
Great. Thanks, Pawan. Yeah.
yeah, so that is one thing. Like another question, like can Kafka be used as ETL similar to Apache Airflow, detect CDC and transform? Yeah. So, apart from this traditional messaging queues and messaging brokers, like one advantage with Kafka is Kafka has a lot of connectors, so you can actually connect Kafka to many providers like SQL or so. I'll just go through like Kafka connectors. So it has like connection connectors to almost like many of these things. So it has like a JDBC source sync, and then it has like Elasticsearch server sync, Amazon S3 sync. It has like HDFC, so it can actually connect with any of these things. And then if there are any changes or if they are actually publishing any messages, like Kafka can retrieve them, and then we can provide them to the consumers. So in these items, they can actually act like a producers. Okay, so you can see the list is actually growing. So you have a lot many connectors. See FTP as a connector, GitHub source is connector, and then so there are MySQL source, like MySQL source. So I actually worked on this, like MySQL source with the help of like Debezium. So the question here is like, so can I actually detect like any CDC changes? CDC changes are nothing but like change capture detection. So let's say like we have a row in MySQL table, and if someone is updating the table, updating that particular row, I wanted to know, I wanted to get that information on what is actually updated. So that is actually possible with Kafka. So Kafka has connectors for MySQL with the help of like Debezium, and it has so many RabbitMQ as a source, so Redis as a sink. Okay, so source and sink. So one is, if it is like source, it is nothing but like the publisher, and then sink is nothing but like the consumer. So PostgreSQL, like the source, it is nothing but like source. It can read only messages from PostgreSQL, but it cannot actually write data to PostgreSQL. Like there is no sync option over here. See, like there are like multiple providers, like tons of providers that Kafka is actually providing. So this is one of the major advantages of Kafka when compared to like traditional queuing systems or message brokers. Okay. Yeah. So mm, can we change retention? Now it is 7 days, right? I thought changing it to 10. Yeah, so that is actually possible. So simply like what you need to do is like you need to stop the Kafka server, and then you can just update this particular configuration entry and restart Kafka, and Kafka will take care of deleting all these old messages. So that is possible. So is it possible to use these tools for maintaining transactional activity like in finance domains where you have to maintain the correct updated amount in the case? Yeah. So one more advantage with Kafka is, so it is actually possible to have like, so even though like I have n number of consumers, so you can see like we are actually writing all the data in a sequential manner. So I cannot actually go back to like first message, read second message. So ordering is guaranteed. So let's say like the first message is something like 5 rupees is 50 rupees is debited from my account. So that is the first message, and second message is something like this. So it is actually credited into my friend's message. So you'll have this in the order, sequential order. So you will not receive like the debited message first and then credited message second, some kind of thing. Like it's all sequential. As these messages are sequential, so you can actually use this for any financial transactions or anything of that sort. So what is the ratio we should maintain as number of partitions and then the number of consumers? So usually, like it depends upon the data. So if we are okay to lose the data, so we can simply go with like a single partition and then single consumer. So just in this case, so in my local case, so I have only single partition. But if something goes down and then the Kafka went down or hardware failure occurs. So if it is like hardware failure, so then only we'll lose data even in this case. So if the Kafka went down, so I can actually, as the data is actually present in the hard disk, so I can read this data like existing data. But if the hardware, like if the hard disk itself crashes, so I lose all this data. So if I cannot afford to lose this data, so I can have like another replica. So usually like people try to have like three replicas kind of thing, and it all depends upon the load also. Like, so it's all like the business need, like, so what ratio it should be like. So usually like it is better to have like at least two replicas.
Yeah, always a failover is
Yeah, good.
There is a question or a suggestion from Santosh in chat. He's asking,
Hmm.
are there any best practices while implementing Kafka for better performance?
Uh, so are there any best practices while implementing Kafka for better? Yeah. So this again will actually go to a separate topic itself. Like, so I was actually mentioning, right? So the partitions. So the partitions usually like help us, like, so more the data we wanted to process, like the more number of partitions we can create. So partitions usually help us to parallelize the data processing on the consumers itself. Like, and there is also a concept of like Kafka consumer groups. So let's say like if I start like two consumers with the same name, like test consumer group, so they together come as a consumer group. Okay, so the group ID should be same. It is like the text like which we provide. So if we have like two consumers with the same group ID, so they actually form a group, and then they share the load of processing these messages. So and that again, like, so it is interlinked with the partition. So I also have a demo for the partitions and then the consumer group. So maybe like we are running out of time, right? So and it's all like again a majority big concept. But like the best practice would be like, so if we as the load increases, like, so we can actually create like multiple partitions, and then at the same time like we can have like multiple consumer groups which are processing this particular thing. So it is like partitions and then consumer groups. It helps us, which helps in increasing the throughput. Okay.
Fantastic, Pawan. Hey, I think one suggestion